Hello everyone. In this project we want to make a digital test bench or workbench. So as you know, in any digital system and digital lab, so you actually need to able to see and check the input and outputs. So and your input output just could be 0 and 1. So that means if you have input, you should be able to give 0, 1 with your inputs. And also if you have the output, you need somehow know that output has 0 and 1. So whenever you use the TTL ICs, so the 0 digital is 0 volt, and depend on the IC that you use in the TTL, that's 5 volt. The 1 is the 5 volt that you have. So in this project, we want to make a test or workbench that able to produce 0, 1 input and also able to check the output and see they are 0 or 1. In the other words, they are actually 0 or 5 volt. So for the input, we use actually the switch. You see with this switch, each of these switch is actually one input. So if we connect each of these if we connect the wire for each of these inputs that we have here, for example, this one or the next one, we should be able to produce a 0, 1 with this corresponding switch that you have. So here, for example, I connect this to the second switch. So that means with turning on and off, I'm able to make here 0 or 1 volt. I need this in the other lab experiment that we have. In the other side, I want to have some LEDs, which is if I have one output light, this wire, it's able to give 0, 1 in digital system. I want to able to put this output here on this LED. If this is 0, should be these LED should be off. It is 1, it should be able to shows this is 5 volt or 1. So that means turning the LED off means whatever I have as output has the 0 volt. If this is on, it means this have the 5 volt. So we actually design the circuit and implement the circuit to test that. So if this, I put this wire here on the second switch, which is able to produce 0, 1 and connect the same thing to one of these LEDs, which is my output. Okay. So because it's turned these LED on, it means whatever I produce here as input, it is 1 and it's able to show with turning on this LED, it shows, okay, whatever I have here on this wire is 1. So see here it's able to produce 0. Right now it is 0. That's the reason this is off. So that means with turning this switch on and off, I'm able to actually check the wire and see it has the 0 or 5 volt. So whenever we do any experiment, definitely in any digital circuit, you need to some inputs which are able to give a 0, 1. We use actually these workbench, which is this switch able to produce 0, 1 for us. And for checking our outputs, see they are 0 or 1, we just use this LED bar and see our output is 0 or 1. If I actually test the other switch that I have, for example, to test the first one that we have here, so right now see this is 0. Whenever I put in the other side it is 0, 1, and as you could see it's able to make 0, 1. We keep this workbench in one corner of our breadboard, and we implement our other experiment in the other section of the breadboard. Whenever we need to check the outputs, we use actually these LEDs. If we need put some input 0, 1, we use actually these inputs that we have and give the 0, 1 based off the needs that we have. So for this project, we just want to see how we could make this workbench and actually keep that in one corner of our breadboard and use that as a work or a test bench. Here just I mentioned to this component that we use. So this is actually the switch that we use. See, this is a switch bar. So as you could see, each switch has one pin here in both sides. So with turning this switch on and off, it's actually connect these two pins together. So we use actually the LED bar, which is similar with the LED, but they put the all LEDs inside the one bar. So definitely one of these is anode and another is the cathode for each of these LEDs that we have. For knowing which side is anode, which side is cathode, you just could able to put the small resistor series with the power supply. I just connect positive to here, negative here. If it's work, so this side is the anode, this is cathode. If it doesn't work, you just reverse the power supply and connect the negative here, positive here. So if it's work, definitely the negative should be cathode and this should be anode. So also we have the resistor bar. So this is the resistor bar. So this is actually too many resistor which they put inside the one bar. Usually one pins that you see here, it is the common pins, and the other pins is the other side of the resistor. So that means in this resistor bar, I have one is the common, and I have 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10 resistors. So how you could use that? You could actually use the common pins and any of these pins that you have. For example, if this is 1K resistor bar, so the resistor between these common and each of these pins that you see, you have just 1K. So usually there is actually a mark here that you see and you know which one is the common, and you actually use all of them, which we use these two resistor bar here. So let's check the circuit and see how we could make and design these work or test bench for our digital lab. So let's check the circuit diagram. So as you could see, this is the circuit diagram for our input port. So this is our switch. So which is one side of the old switch in switch bar connected to the ground. And the other side, you have these resistor bar, which is 820 ohm. So the common pins of the resistor bar connected to the 5 volt. And the other side actually connected to the other side of the switch, and our input is this common place that we have. So let's see what's happening in this circuit. Whenever this switch is open, you have these 5 volts. So that means in input you have one digital 1. So whenever you close this switch, so you have 0 here. So that means you have 0, digital 0. So that means with turning on and off these switches, you are able to produce 0, 1 in your input port. This is what we want. So let's check our output port. So in output port, again, we use the resistor bar. This time we use 390 ohm. So the common pins of the bar connected to the ground, and the other side of these resistors, which you connect to the cathode of these LED bar. To just make sure, test your LED bar and make sure which side is the cathode, which side is the anode, and connect to the cathode to the other side of your R. So if you have the output and you want to know that is 0 or 1 digital, in other words, it is 5 volt or 0. So if you connect these to this side, if it's 5 volt or 1 digital, definitely it's turned on these LED. So if this is the 0, so definitely the LED is actually off. So that means turning on and off the LED, you could know whatever you have in the output is a 0 and 1. So let's implement these two circuits and see the circuit works or not. So we implement the circuit. So let's try first our input port, which is we could actually produce 0, 1 with this switch that we have. So if I connect one of them to the output port, so let's actually test the first switch that we have. If I put that here, it should be with turning on and off this switch. It should be able to produce 0, 1 inside this wire. So for testing that, I just put that in one of these output port that we have. So as you could see right now, it's produced 0. It's actually turned on the LED. So if I put these in the other side, so it's actually off. So that means with each of these switch, I'm able to produce 0, 1, and these output port able to know or detect 0 or digital 1 or 0. So be turning on and off the LED. The LED is on means I have 1 here. So if the LED is a 0, it should actually means this wire has 0. So as you could see here, I could produce 1, 2, 3, 4, 5, 6, 7, 8, 9. I could almost have 9 input. I could make 9 input and produce 0, 1. Similar here, the number of the output that I could check is equal to the number of the LEDs that you have here. So I hope you like this project.